we take a look at the world around us and what everything is fundamentally made of, we think about atoms. Atoms come in different varieties, called elements, and is a unique combination of these elements that make up everything, from inorganic objects like metals to organic materials that make plants and animals. Even the air around us comprises of atoms of different elements. Have you ever wondered where these elements come from, how they were made, and how they ended up here on Earth? The answer to this question lies deep within the hearts of stars.
Stars are massive objects and can live for millions, sometimes billions of years. They're able to maintain stability due to a continuous battle of two forces, gravity and nuclear fusion pressure. Nuclear fusion is a process in which stars fuse smaller elements into larger elements. This generates a lot of energy and light and causes an outward force to be exerted from the core of a star. On the other hand, gravity is constantly pulling all the matter of the star towards the center. This balance of forces that keeps the star stable is known as hydrostatic equilibrium. Okay, so now we know that stars can fuse different elements through the process of nuclear fusion, but this is only one piece of the puzzle. To get the whole picture, we must look at the later stages of a star's life. Let's take a look at how a star evolves as it fuses larger elements. We can see that as it fuses larger elements, it begins expanding very rapidly. So far, we've fused every element up to iron, but this is where fusion stops. This is because the fusion of iron atoms takes more energy than it releases. At this point, without nuclear fusion to cause an outward force, gravity takes over and the star begins to collapse inward.
Once a star begins to collapse, different stars yield very different results. Let's take a look at one of these cases, a very massive star, one at least 20 times the mass of the Sun. By the time a star like this has fused every element up to iron, it would have expanded into what is known as a red supergiant. Red supergiants are at least 200 times the size of the Sun. Let's make a comparison. If the original size of the star is this tennis ball, then the size of the Sun would be this small bead, and the size of the resulting red supergiant would be this large exercise ball.
When a red supergiant collapses, it results in a supernova explosion, one of the brightest events in the universe. Matter falls quickly towards the core of the star, and ricochets outward, causing the explosion. A good way to visualize a supernova is with a stacked ball drop. At this point in the supernova, when all of the matter of the star is densely packed near the core, an incredible amount of heat is generated, resulting in the synthesis of every naturally occurring element heavier than iron. After the supernova, most of the matter that was once contained in the star is scattered throughout space.
This scattered matter creates a cloud of dust known as a planetary nebula. This nebula contains all of the necessary elements for the formation of new stars, planets, and of course, us. Thanks for watching.